Hi everyone, Mrs. Jones here. In this video, I am going to give you a quick introduction to something called projectile motion. Hopefully, as you see on the screen here, you're recognizing parabolas and some different ways that we see parabolas in the real world. We have a football player, a basketball player, someone jumping off a diving board. The idea here is that we are actually going to use our knowledge of quadratics to represent these parabolas in what we call projectile motions. So here we go. So the formula for a projectile motion is shown on the screen, and it's pretty fancy. But what I want to remind you is that this really models the same standard form of a quadratic equation that you already know, right? We have our y equals ax squared plus bx plus c. I know the black equation has a lot to it, but the red equation is quite similar. So let's dissect some of what we know here in the black equation. H of t. H of t is going to represent the height at a certain time, meaning the height is a function of time. G is going to represent gravity, and it's going to be a constant. So for our sake, the gravity, we're always going to work in feet, which means gravity is always known as 32 feet per second squared. T, I'm hoping you guessed, represents time. V sub 0 represents the initial velocity, the upward velocity, which you'll learn more about later in future math classes, but essentially it's a combination of the angle and the speed that the object has when it first starts. And h sub 0 is the initial height of the object. So both the velocity and the height are both at the start when they're launched into the air. So let's try an example. We know that Bob stands at the edge of a canyon 100 feet above the canyon floor. He throws a rock into the air with an initial upward velocity of 48 feet per second. So we have our initial formula here, and what we're going to do is we're going to plug in the information we know. We know that gravity is 32, we know that the initial velocity is 48, and we know that he is at an initial height of 100. So when I plug this in, it's going to look like that. But what I can do here is I can actually simplify this portion of the equation. So my new equation is going to look like this. H of t equals negative 16t squared plus 48t plus 100. So our first question is, how high is the rock after 2 seconds? Knowing this, we are trying to figure out what happens when t is 2. So what I've done here in my work is I've plugged in t of 2 wherever I see t. So in the end, when we solve all of this down, we know that after 2 seconds, the rock is going to be 132 feet in the air. All right, the next question says, when will the rock return to the same height as Bob? Well, what this is asking is h of t is going to equal 100 because that's the height of which Bob started, or the rock started at. What you see in my equation here is that I'm actually showing the equation equal to 100, but in the blue, I've canceled out the 100. And the reason for that is it's the same on both sides, so it can cancel out. I then have 0 equals negative 16t squared plus 48t, which I'm hoping you recognize as some ZPP. When I factor, or when I undistribute, the negative 16t, I end up with two solutions of 0 and 3. Keep in mind that the 0, we already know that's when the rock started in the air. So it's this 3 seconds that matters, right? The rock is going to go up and come back down because of gravity. So at 3 seconds, it'll be at 100 feet again. All right, the next question says, when will the rock hit the floor of the canyon? So h of t now is going to equal 0 because I want its height to be 0. So when I plug this in, it's going to look like this. And I'm hoping you recognize that we're going to need to use our quadratic formula. Now the quadratic formula gets quite fancy here. And we end up with a radical that needs to be simplified. So this red answer here is our most simplified answer. But what I've done is I've converted it into a decimal so that it can make the most sense to us. We have two answers, a negative answer and a positive answer. This negative answer means 1.4 seconds ago in the past, the rock was technically on the canyon floor. But we know that doesn't actually apply here because we know the rock started 100 feet above the canyon floor when Bob threw it. So it's this positive 4.4 answer that makes sense to us. We know that in 4.4 seconds in the future, it will land back on the canyon floor. All right, this next question asks, when will the rock reach its maximum height, and what is that height? I'm hoping that you are seeing the word maximum and you're thinking about the vertex. Remember, our vertex form is y equals a x minus h quantity squared plus k, where h comma k is our vertex. So what we're going to do is we're going to use completing the square to help us. I'm going to first look at my first two terms, and I'm going to factor out this negative 16. So I'm going to be left with h of t equals negative 16, and then I'm going to have t squared minus 3t, because I've taken out that negative 16. I'm going to leave a blank here because I'm going to complete the square in a moment, and then plus 100. So what happens here is we are going to complete the square. I'm going to fill this in as being 2.25. Hopefully remember from last week, we're taking half of this value and squaring it to get to complete the square. Now, what we've actually done here is I'm going to distribute this negative 16 in a second. And what happens is I've actually, I'm subtracting 36. And I need to undo that. I need to keep my equation balanced. So I'm going to add 36 here. So when I bring this all down into vertex form, I'm going to end up with h of t equals negative 16 parentheses t minus 1.5 squared plus 136. This is my vertex form of the equation. A few things of how we got there. Remember, we had to add the 36 to balance out our completing of the square, so we have 136. This 1.5 came from my half of this b value, okay? Now we have our vertex. I know that my vertex is 1.5 comma 136. So we now know the highest point was 136 feet after 1.5 seconds. What I want to do is I want to show this to you on Desmos. I want to quickly recap this problem for you so you can see it all together. So here's our initial equation, and we see the path of the rock. Obviously, the rock is starting at this point here. Okay, we know that's where Bob started. Our first question was after 2 seconds. We can see here that after 2 seconds, if I get it right, there we go. After 2 seconds, it was 132 feet. We wanted to know again when the rock will hit 100 feet, right? So it's going up and then gravity's bringing it back down. So right here, we see that 100. After 3 seconds, it's at 100 feet again. Then we wanted to know when will it hit the floor. Remember, we had about 4.4 seconds. And the last thing we just learned was its vertex of 1.5 comma 136. All right, I'm going to ask you now to pause the video here. I want you to try questions A and B related to Vicky and her throwing a ball in the air, and then I'm going to help you with part C. All right, you're back. So how tall is the building? The building is 56 feet tall. When will the ball strike the ground? In about 6.54 seconds. And now we're going to look at what is the ball's highest point. So again, we are trying to take this equation here and turn it into our vertex form. So I'm factoring out that negative 16. As a result, I end up with t squared minus 6t, and I need to complete the square. So what I'm going to do is I'm going to add 9. In doing so, I'm really subtracting 144. So in order to balance that, I need to add 144. In completing the square, my vertex form becomes negative 16 parentheses t minus 3 squared plus 200, which means my vertex is 3 comma 200, which means the highest point of the ball is after 3 seconds. It's going to be at 200 feet. All right, one more. I want you to pause here and try these 3 questions about Bobo. All right, first one, the equation for Bobo. There you go. When does Bobo hit the water? At 2.7 seconds. And how high above the water does Bobo get? So thinking about our vertex, right? At 46 feet. All right, just to recap quickly for you here with projectile motion's basics. If you are asked a question of what time will something happen, if something you want to know when will it hit the ground, you are plugging in 0 for h of t. You're setting the equation equal to 0. If you're given some sort of height, for instance, 10 feet, you're going to set the equation equal to 10. And if you want to know the highest point, you're looking for the x value of the vertex. Okay, at what time? So how high will it be at a certain amount of time? So if something, for instance, says that how high will it be after 3 seconds, you're going to plug in t of 3. And if you want to know how high will it be at a certain point, you're looking for the y value of the vertex. So I hope this makes sense. I know that was a quick introduction into projectile motion, but if you have any questions at all, please just ask. We're happy to help, and good luck.